Greetings hobbyists, this is Add Ons of All, and in this video we're going to look at how you can quickly remove internal cavities from models in Blender. So this video was a request from David, and it is a really good topic for a video. It seems relatively small and unimportant, but for 3D printing, internal spaces in a model are really disastrous potentially. It will lead to the resin eventually corroding the internal parts of the 3D print, and eventually that resin is going to get out and leak everywhere, and if it's for a miniature, totally destroy your paint job. So this issue can be easily created yourself by accident. Here we've got a load of spheres that I've booleaned together, and because of the way they interact, in the middle here we can see that we've got a slight cavity. If I just go into edge mode, we can see this a little bit more clearly there. And that is going to trap resin in it, which is going to cause problems later if we were to 3D print this. I should also add that 3D Builder, which is a massive favourite program of mine for fixing 3D printable objects, can on occasion cause these problems when trying to fix objects with a lot of internal overlapping faces, which is why I always recommend using Blender to boolean objects together and then using 3D Builder just to test them, not as your main source of combining objects. The other issue that's worth noting is that if I come to my 3D print toolbox, if you don't have this, just go to Edit, Preferences and type in 3D print toolbox. It will come up and you can select it. If you have got Blender 4.2, you'll need to find that in the extensions and install it first. But if I check these, while this will note down my intersecting faces and zero faces and non-flat faces, it doesn't have something to check internal geometry, so this won't actually show anything for us, which is a really big problem. Now this is quite a complex object, so if I just bring in a cube here, let's just do that and then duplicate that and make it smaller, and then we'll just delete this from it, and then we can check here. You can see we get no issues here, only the overhanging faces, which is to say that there is a face here and a face there that are facing downwards. It's not telling us anything about the object. So this can be a real problem, and we need to know how we're going to solve this. So what I've got here is a nice skull. It's a really cool model, loads and loads of detail. It'd be awesome to 3D print this. But frustratingly, there is a hole in the middle where they've modeled the space for the brain. So we can see that here. And this will cause a lot of 3D printing problems because it's such a big space. It's probably going to cause problems with the supporting of the model, and definitely it's going to leave some resin internally to it. Now we've got several options of how we're going to fix this, so I'm going to make two duplicates of this. And we're going to talk through both methods and make sure we understand what the positives and negatives of each are. The first is probably the easier method. It's definitely quicker, but it is the one that's likely to cause some potential issues, especially if you've got STL files from online somewhere and they haven't been very fastidious on how they've combined everything together. So what we're going to do is go into any form of edit mode. Now I've got machine tools, so I get this pie menu, but you just need to hit tab and go into whatever mode you like. And then if we go into X-ray mode, we can see these internal spaces. I'm just going to click off. I'm not sure that makes it actually any clearer. Either way, what we want to do is tell Blender to look for the bits that aren't connected to something else. And even though this is an internal space, Blender will think of this geometry as unconnected to other objects as long as it is not touching any of the other outside spaces. It's quite difficult to demonstrate this here, but it's not actually in contact, or there's no edges going between this space and the external space. So what we can do is just have everything unselected, and we can press P and we can select separate by loose parts. Now what that's done is that has broken down all of my other parts. You can see it has now spaced them into lots of other objects. We'll come to that. And then I can click, if I go into object mode, on this internal space, G to move it, and we can now just delete out that brain-shaped cavity. So let's just delete that out, and now we don't have this problem. But we have gained another problem. Let me just explain what this problem is. And that is, if we come to this skull, this has been designed in a way that people often do with STLs, and it is, just to be frank, a little bit lazy. What they've done is they've just joined everything together without using booleans, and while there are uses for this, we can see that certain of these parts, for example this part here, this tooth, if we look in X-ray mode, has got all of the internal detail. It's not actually connected to the skull. And what this has meant here is that all of these individual parts have now been made separate. Now this means that we can start booleaning these together again if we want to. So this is fixable, but it just adds a bit of extra time. However, the initial method itself is very fast. The second method we could use is a little bit more selective, but a little bit more tedious to do. If I just go into X-ray mode and we will go into face mode, what I need to do is select this internal geometry, and this is a little bit messy. Now the easiest way to do this is to literally just scroll until you are inside the space. Let's go out of X-ray mode, and then we can see the internal part. And all we're going to do is click a face to make sure nothing else is selected. In theory, you don't need to have done this, but I always do it to make sure I'm not selecting something else. And then if you just hit L while you're on part of that internal geometry, it will select everything that's linked. And if we zoom out now and go into X-ray mode, you can see that it has just selected all of that geometry that's connected together. You can also use this for other bits. For example, if I wanted to, I could press L and select just that jaw. So it's really useful as a tool. But here that's going to allow me to press G, move that out if I want to keep it separately, or even when it was inside, I could just press delete and delete all the vertices, and that internal set of faces and geometry is gone, solving that problem. So now you're free to 3D print this model without any concerns about internal cavities and leftover resin that's going to ruin your model at a later date. Hopefully that's been helpful. If it has, please do hit that like button. It really helps share the video around and make sure other people suffering from the same issue to solve them really easily. Have a great day, guys. The difficulty is that this problem is quite easy to create when making a model, generally unintentionally. For example, here I've got a load of spheres which I've sort of turned to this blocky smudge, and if I just select all of these and then combine these together, the problem is that this issue is easy to create, generally unintentionally. For example, we've got a lot of spheres here, and if I just start combining these all together just with booleans, as we might do in a project, we can end up with this internal space that you can see here, and that is going to lead to this exact problem. David hadn't The issue is that this is a very easy problem to create yourself, generally unintentionally. For example, here I've got a load of quad spheres. What I did is boolean these together, and if we look at this in X-ray mode, we can see that we've got this internal cavity where resin is going to get trapped. I can just make that clearer here so we can see that. Now, in David's instance, he was asking about this for files taken from STLs and other places, and this can also be created when programs like 3D Builder attempt to fix issues in geometry where there's sort of internal faces crisscrossing over each other, which is why I always I'd always recommend using booleans to combine everything together and then check it in 3D Builder, not the other way round. We can also see this in this skull model that I've just got here. It's a really nice model with a lot of detail to it, but we've got this internal cavity where the brain should be, and we don't want to have that there for 3D printing. So let's have a look at how we're going to solve this. Now, there are two methods of solving this, and they each have their own differences and can create problems depending on the model that you've got. So what I'm going to do is just duplicate this out to the side, so we've got two versions of this skull. So the first method we could use is by just... And I should mention that if we go to 3D Print Checker, so that... And I should mention that if we go to 3D Print Toolbox, if I go to Edit, Preferences, 3D Print Toolbox is here, this will not recognize this as a problem. And it's important to mention that 3D Toolbox, and I think it's important to mention that 3D Toolbox from Blender won't even recognize this as an issue. So let's have a look at this and what we're going to do. So the first thing we're going to do is go into X-ray mode with Shift and Z, so we can see everything, and then I'm going to go into any of the edit modes. I've got this using machine tools, but you can just go into any mode of machine. But you can go into any mode anyway, just by hitting tab and selecting the option